All right, for Math 1, this was our homework for today. We need to solve for x. For our first problem, we actually have enough room to do them underneath. And we can say, I need to get x by itself. Every single time I say solve for x, you need to get x by itself. X is by itself if I get rid of this 3. I can't just move the 3 and just say, oh yeah, I'm going to move it over to the other side. That does not work. No, 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 no. The way that you do it is you do inverse operations, or you do the opposite of plus 3. The opposite of plus 3 is minus 3. So in this case, I'm going to say minus, I need to find a better color though, don't I? Minus 3, maybe I should make it pop and say minus 3, minus 3. Whatever you do to the left side of the equal to sign, the equal to sign is the great barrier. Everything that's on the left side of that barrier, you need to do that to the right side of that barrier. I have a minus 3 on the left side, therefore I have a minus 3 on the right side. And when I do that, 3 minus 3 is 0, which means they just cross off. I'm left with just an x. X is equal to, and again, whenever you write your equal to sign, you're doing it directly underneath, as if it's a giant wall of equal to sign, equal to sign, equal to sign. And then over here, I need to figure out 9 minus 3 is what? 9 minus 3 is 6. So there's our first answer. Okay, I'm going to rewrite my 3x plus 15 over here, and I'm going to say this is problem number 2. Problem number 2 is 3x minus, or 3x is equal to 15. For this problem, I need to get x by itself. It says solve for x. Okay, so if x needs to be by itself, I need to undo this 3. I need to get rid of the 3. Well, again, we talked about hidden math today. The hidden symbol in between 3 and x is a multiplication symbol. So this really says x times 3. I'm multiplying backwards. So if I'm trying to undo multiply by 3, we divide by 3. I know a lot of people want to say divide by 3 like that. Here's the way that we do it in high school. In high school, we say divide by 3 with a fraction. And it's nice to see that work, because when I divide by 3, I just cross off the 3. If you have the same thing on the top and the bottom with multiplication, you just cross them off and you're left with just the x. So I'm going to rewrite the x down here. Again, where do I write the equal to sign? Ooh, I didn't mean to do undo. The equal to sign is directly underneath. I'm going to put it right here. And then finally, I have to figure out what is 15 divided by 3. 15 divided by 3 is 5. Once you get your final answer, you box it. All right, let's try number 3. I'm going to rewrite it up here. Number 3 was 2x plus 3 is equal to 11. Okay, so now we have a mixture of multiplication and addition. With multiplication and addition, you look at my good friend PEMDAS. Please excuse my dear Aunt Sally. So again, whenever we simplify, if we had no variables, we do this direction. We call that simplifying. Let me turn my screen on the side and say this is simplify. That's without any variables. But if I have variables, I need to solve, and I go the other direction. If I'm going to go from the bottom to the top, that's solving, which means I'm first trying to get rid of addition and subtraction. So do I see any addition or subtraction I can undo? Oh, look at this one, some addition that I can undo first. I'm solving, I'm going from the bottom to the top with PEMDAS. So I'm going to undo this 3. The way that we undo that 3 is we do the opposite of add, we subtract. We subtract a 3. And again, I look at my wall of equal to signs. On the other side of that wall, we also subtract a 3. Subtract a 3 on this side. And then we rewrite this. Okay, so the left side, 3 minus 3, those are gone. We just say they're canceled out, and you're left with just this 2x. Let's go ahead and rewrite that down here. We have a 2x. Again, we have this giant wall of equal to signs, so the equal to sign goes right here. And then I have to figure out what is 11 minus 3. 11 minus 3 is 8. All right, and then we do the next step. Again, it's very obvious what we do next, but if you go up a level for PEMDAS, you can say, is there any multiplication or division that we can undo? Well, yes, there's a hidden symbol in between here. That hidden symbol is a multiplication. To undo multiplication, we divide. We divide both sides by the number that's in front of x. In this case, we divide both sides by 2. When we divide by 2, notice the same number that's being multiplied on the top and bottom, we cross cancel those, and you're just left with this x. We can bring that x down here and say x is left over. X is left over, and that's going to be equal to, okay, again, notice how all my equal to signs are in a giant line here. They're right in this right spot. 8 divided by 2 is 4, and we get our final answer. All right. I'm running out of room here. Let's do, I'm going to do like a little squiggly sign. Okay, here's number 4. Number 4, I'm going to copy that down again. I have 5x plus 4 is equal to 3x. Okay, in this problem, I have an issue, which is I have variables on the left and variables on the right. So the only way that you can solve this is to choose which side the variables should be on. Should the variables be on this side? Should the variables be on this side? I don't know. Well, you can ask the other question, the constants, the non-variables. Which side should the constants or the numbers, the non-variables, what side should that be on? Well, I only have one constant and it's on the left-hand side. There are no constants on this side over here. If I had like +3, then it would be a better question. This side is already reserved for the constants, which means the variables should all be moved to this right-hand side. You don't have to do it this way. This is my suggestion to you, but you do somehow have to move the variables. So if I already have the constants on the left, let's move the variables to the right. The way that we move variables is we get rid of that 5x by subtracting 5x, minus 5x. Whatever we do to the left side of that equal to sign, we do it to the right side of that equal to sign. So we say minus 5x on the right side of that equal to sign. Notice that the 5x minus 5x is gone, leaving behind just this 4. You can write down a positive 4, but it's more correct to say just 4. Okay, this is a little bit tricky. When I do 3 minus 5, you always take the sign of the larger. Whenever you add and subtract, this is a universal rule. Whenever you add and subtract, you always take the sign of the larger. 5 is larger, so we take the sign of the minus. So it's definitely going to be a minus. Okay, notice that these have opposite signs. Whenever you're doing things with opposite signs, with adding, subtracting, you're always going to subtract. So I'm going to kind of ignore the negative for a sec. I'm going to subtract 5 minus 3 and I get 2. So the answer is going to be -2 and it's still x. The variable is still there. This is saying how many pieces of fruit. I have 3 pieces of fruit. I need to give 5 pieces of fruit away. I'm 2 pieces of fruit in debt. That x is the pieces of fruit. And then finally, we need to get rid of that pesky number in front of the x. Remember, there's a hidden symbol in between here, a multiplication symbol. To undo that hidden multiplication, we need to undo it with division. The way that we write division is we say divide both sides. And that I can do, can I do it in white in this case? I can divide both sides. I can divide both sides by whatever this number in front of x is. That number is called the coefficient, by the way. We can divide by that coefficient. We can divide by that -2. Divide by -2, divide by -2. And look at this. You're gone. You're gone, leaving behind just this x down here. Just this x down here. And then again, notice how all of my equal to signs are in a giant line. That means my equal to sign is right underneath here. And then I can ask myself, 4 divided by 2 is just 2. A positive 4 divided by a positive divided by a negative is a negative. And I get my final answer. All right, last question. I think I'm going to need some new paper. Let me go ahead and just copy and paste it. So I'm going to say the equation is 2x plus 18 is equal to -3x minus 2. I need some paper, so let me copy and paste this onto a new piece of paper. So I'm going to copy you, and I'm going to add a new blank piece of paper, and I'm going to paste it right here. This is, what? How's that? What? That's not copying and pasting. Come on. I'm going to grab you. I'm going to copy. I'm going to come over here. I'm going to hit paste. There we go. Okay. This is question number 5. For question number 5, we have to ask ourselves, where do you want the constants? Where do you want the variables? There's constants on both sides. There's variables on both sides. So there's not really a wrong answer, but in general, the easiest path forward is to choose variables first. So I'm looking at you variables, and then choose the side for the variables that has the most positive. Well, 2 is the most positive. Well, one's negative and one's positive. So it is the only one that's positive. This should be the side where the variables go, which means this variable needs to move over here. The opposite of -3x is to add 3x. And we do it to both sides of the equal to sign. There's my wall. I did it to one side. I need to do it to the other side. Here's something that's slightly incorrect. You could slightly be incorrect by saying add 3x. Well, it's technically correct because you're adding it to the other side. Notice that my 3x has not been written underneath the other variable. X is a variable. It should be rewritten under the other variable. I should really be moving the 3x right here. So let me go ahead and move my 3x to the other variable. Now it's more correct because these are my like terms. Those are my variable terms, not my constant terms. So what do we have? We have -3x and positive 3x, which cancel each other out. The equal to sign, let me write that first, is directly underneath. The 3x and 3x are gone. I'm left with just a -2. I'm going to go ahead and rewrite my -2. On my left-hand side, I have like numbers. I have variables. I can add my variables. If I have 2 x's and I add another 3 x's, I have a total of 5 of those x's. And I do need to copy down, once again, my positive 18. From here, I'm going to solve for x. To solve for x, I need to move everything on the other side. Remember, we already said the left side is reserved for the variables. Therefore, the right side needs to be reserved for the constants. This 18 needs to move over to the right-hand side. The right side will be where all the numbers, the non-variables, the constants will go. So this 18, we're moving it over. To undo plus 18, we are going to minus an 18. If we do it from the left-hand side of the equal to sign, we need to do it to the right-hand side as well of the equal to sign. So I'm going to say minus 18. Notice that the 18 and 18 are going to cross cancel, leaving behind a 5x. Let's go ahead and copy down 5x. Notice my equal to signs are all in a line. That means my equal to sign is going to live right here. Over here, I have two of the same sign. Whenever these signs match, you always take the sign of the larger, it's still a negative, and then you add them when they're the same sign. 2 and 18 add up to 20, so it's going to be negative 20. And then finally, we're going to get rid of this coefficient. I'm trying to solve for x by itself. I'm not solving for 5x, I'm solving for just x. Remember, there's a hidden multiplication symbol. To undo multiply by 5, we are going to undo it by dividing both sides by 5. So I'm going to divide by 5. If I divide the left-hand side of the equal to sign by 5, I'm going to divide the right-hand side by 5. 5 and 5 are going to cross cancel. They're gone. That's leaving behind an x. Therefore, we're done. The answer is whatever this is. I'm going to ignore the sign for a sec. 20 divided by 5 is just 4. A negative divided by a positive is a negative. Therefore, the final answer is negative 4. That concludes our homework. Thanks for watching.